test right there. Thank you. Okay, guys, we're going to do constructions, and the first one that we're going to construct is going to be an isosceles triangle. Okay, so this is how we do the isosceles triangle. Okay, now I know it's been a while since we've done constructions, but hopefully you guys remember how to do the segment, right? Anybody remember how to do the segment? The first thing you're going to want to do is start with a ray. So you can put a ray anywhere on your paper, right? But I recommend that you do it at least halfway down, if not, a third of the way down. Okay, so just draw a ray, use a ruler, okay, always use a ruler. It's up to you. I mean, but I would say at least a third of the way down, maybe even 2/3, if you will. You want your triangle to be above the ray, not below. Cassidy, can I get you to pull the screen down a little bit further so I can see the tools? Thank you. Okay, so the next thing you want to do is get your compass. Okay, and you want to take your compass. Oops, sorry. You want to put the pointy end of your compass on the end of the ray, right? And you're going to take the pencil end and you want to widen your compass to about how big you want the bottom of your triangle to be. So like however wide you want it to be, just kind of open it up. Make sure the pointy end's on one side. And then once you do that, you're just going to do a little arc right there. Okay, and that's going to give you your point for the other side of your triangle. So then you put like a dot there for the vertex. Okay. Put the point in, yeah, put the point right there. Okay. And this is going to be the length of your triangle right here. Okay. Now, since we're doing an isosceles triangle, the next thing we want to do is find the perpendicular bisector of this line. So to do that, go ahead and put your point back on the same point. You want to open up your compass so that it's more than halfway, but not all the way. Okay, and you just kind of eyeball it, but make sure it's more than halfway because we want the two arcs that we're about to make to intersect. Okay, so now we're going to draw an arc here, and it's got to be big enough that we think it's going to intersect. And then do not change the setting on your compass. Keep it the exact same width that you have, and go ahead and move the point to the other side. Okay. And we're going to do the same thing from the other point. Okay. But make sure that you have not changed the setting on your compass, because if you change the setting on your compass, it won't work. Okay. You want to have this little fish looking thing. Do you see it? Now what happens is for these fish little things, now you've created 2 points at the top and the bottom. Do you see that where they intersect? That's going to give you the 2 points that you need to make the line of the perpendicular bisector. Okay, so then you're going to make a line, and this is going to be your perpendicular bisector, and it's got to go all the way through. Now I'd make it really tall because we're going to use this line to finish our triangle. Okay. Okay. Now, if you remember, we had that perpendicular bisector theorem. Does anybody remember the perpendicular bisector theorem? The perpendicular bisector theorem said that if we take any point on this line and connect it to these endpoints of the segment, they'll be congruent. Okay, so now just pick any point on this line that you just created, make it tall enough that you got a pretty good sized triangle, and connect your dots. Okay, and you should have an isosceles triangle. Once you've connected the dots, go ahead and measure and see that it is indeed isosceles. How would I know if it was isosceles? Yeah, these two sides would be the same length. They would be congruent. Okay. Yeah. Did you measure and check to see if it's isosceles? Yeah. Okay, so at this point you have now created what? A isosceles triangle. Okay. Okay. Ready for the next one? Okay. So now we're going to create an equilateral triangle. Okay. Now what's the difference between the isosceles triangle and the equilateral triangle? Yeah, now we're going to have all three sides are the same. If we do it right, that's the goal. We're going to have all three sides the same. Okay. So we're going to do the same thing as before. We're going to start with a ray. Okay. And if you notice the common theme, what do we always start with? Yeah, we're always starting with the ray, right? Okay, then you're going to take your compass and you're going to put the pointy end on the end point of the ray, wherever you put that. Okay, and then you're going to stretch it out. Now, this is going to be the actual length of your bottom side, or really all three of your sides, right? So go ahead and stretch it a pretty good way so you know it's big enough, right? And then you're going to want to do an arc here, right? And then you're also want to do an arc. Whoops, don't move. You also stop it. You also want to do an arc way up here too, because you're going to have to get that intersection as well. Yeah. Now, ideally, you would just like arc here and then arc here, but mine won't let me not write the whole circle. So you can either do the whole circle or not. Okay. Now, the next step after you've done that is to move the pointer over here to this point that you did right here, right? And here. Now you're going to do the same thing and you want to intersect up here, right? Oh, I guess that's how I could do it. So I'm going to go right here with my pointer on this particular point where this intersection is, and I'm going to do that. Yeah? Okay. So then I'm going to put my three vertices for my triangle. It's right here at the end point that I started, right here at the intersection that I created here, and then right up here at the intersection that I created here. Remember, once I set my compass from here to here, I didn't change it, right? Tighten it up and leave it just like that. Okay, and now I can do my triangle lines, and I just go connect all the vertices. Okay, now what do you need to do after you connect all the vertices? Yeah, measure it and make sure that it's actually indeed an equilateral triangle. Okay. And so what was this one? This one was my what? Equilateral.